Good evening. Our today's topic is friction, which is very important. Now, friction. When we talk about friction, actually friction is also a type of force which mostly apply on the object or on the particle against the applied force. Now, when we define the friction, then friction force is a force which applies in opposite direction of applied force. But this definition is not true for all object or every time. This definition is a general definition. Okay? Just like what I said that in case of cycling, when we pedal the cycle, at that time friction force applied in opposite to motional force. It means applied force. But when we stop the pedaling, at that time friction force and applied force both are in same direction. But this is the application part of friction. But when we talk about friction, this is the main definition of friction, right? So now this time I consider this definition for friction and solve some numerical also and type of friction also, and we further consider these things with the example of cycling. What happens and why this is valid for cycling in case of cycling. So firstly we consider this one, right? Now when we see the friction, because this chapter is under the Newton's law of motion. So when we see this definition, so firstly the main and the most important thing is free body diagram for this. Now when we draw a free body diagram for a simple mass which is kept on the rough surface, not horizontal surface. So when this is a mass m, here mg applied downward, and normal reaction just opposite to mg. Now here is the mu, it means here is the friction. Actually here is the friction force when we apply a force on this mass, right? And this mass having acceleration a, right? This is the rough surface. So in this case, when we make the free body equation, then we all know about that key. In x direction, x force are minus x plus x, and y minus y, plus y minus y, minus y and plus y, right? We all know about that key. X-axis forces are equate with in a single equation, and y-axis forces are equate in a single equation. So now, what is this? F is equal to Fa equal to this equation, and normal reaction is equal to mg. This two, first equation, second equation. When we consider this, Fk is equal to mu, that is the coefficient of friction. Then here is the mu n. And what is n? N is equal to mg. So we put F is equal to mu into applied the value of mass and the coefficient of friction, then we found the value of force which is applied on this system. Just we consider a numerical value, just like here. Now, here mass is equal to 10 kg, right? And this is the normal reaction. This is the mg, right? And coefficient of friction mu is equal to 0.3. Consider that this, and this is the applied force. Then question asks that what is the applied force at which this mass must move from this place to this direction. Then it is very important for us that this applied force is more than the frictional force. It means when we apply this, N is equal to mg, the first equation, and this F is equal to mu n, that is called this frictional force. So when we apply the value of this frictional force, this is kinetic friction. This frictional force here, N is equal to mg, so mu is equal to mg. Consider here G is equal to 10. G is equal to 10. So what is the value of this equation is? What is the value of this equation is V, and F kinetic is mu 0.3 into 10 into 10. It means F kinetic is 30 Newton. This shows that the applied force is must greater than this kinetic friction force, then only this block move from this place to another place, right? This is the very basic example and very basic explanation about the friction. Now, what is the type of friction? What are the type of friction? If we know about if we think that friction have many types, then we're talking about friction have of three types. First, kinetic friction. First static friction. Second, kinetic friction, and third is rolling friction. It is very important. Third, second. But in most of the book we see that the one friction also considered here like fluid friction. But fluid friction is the part of fluid mechanics in viscosity and surface tension. So we don't consider in the case of friction, because generally we see the question in examination also the mechanical question in fluid mechanics. So we neglect that fluid friction here. Now first is static friction. Second is kinetic. Third is rolling. Now, what is static friction? What is kinetic friction? What is rolling friction? In static friction, the applied force F is less than friction force. This is the main property of kinetic friction. Here, block is at rest. Here, block is at rest. It means in this case, the block is not moved from one place to another place because the applied force is less than static friction. Here, right? So when we consider that kinetic friction, what is kinetic friction? It means here applied force greater than or equal to applied force is greater than or equal to this kinetic friction. It means here first property and second property here, block is either move or about to move. This is the kinetic friction. And what is rolling friction? Rolling friction here applied force is always greater than rolling friction. It means it is free to move from one place to another place. The base example of rolling friction is bearing. Bearing is the best example for rolling friction. Now, when we consider about the example of kinetic friction, just like blue cuts, because blue cuts, when we see them, because we have considered both of them, when the blue cuts, the tire of blue cuts at the road, the tire of blue cuts at road, at that time, it is at rest. Sir, the blue cuts, the blue cuts, the holes apply more force at the time of rest because it is in static friction than rather than kinetic friction. Because when the blue cart is in motion, then the horse applied less force because the friction force is less than static friction at the time of kinetic friction. So when we consider the one question comes mostly in the most of the examination like that, which one is greater according to greatness? So static friction is more than kinetic friction is more than rolling friction. This is the main outcomes comes from this theory, right? Now, when we talk about the numerical part of this question, this equation, then the very important and the very mostly asked question in examination, like this wedge problem, right? When we consider a mass m, right? Mass m which have this wedge have angle theta, and mass m which is mg considered as downward, and the coefficient of friction is mu here, and normal reaction like in this way, and here component of mg is 2. This is theta, this theta, this is also theta. So mg have component mg cos theta, and mg have component here mg sin theta. Now, when we calculate all forces here, then what is the comes out? Like n is equal to, according to friction, y-axis component have 2m, n is equal to mg cos theta, this is first equation, and here is mu n, friction force, mu n is equal to what is mg sin theta, right? This is the mu kinetic friction, right? Mg sin theta. Now, what we did that? What happened? What is the outcome of this? Now, when we consider this two equations, now we saw n is equal to mg cos theta, which is used here, right? Then what is comes? Mg cos theta is equal to mg sin theta. When we cut this mg to mg, then what we found that mu is equal to tan theta, sin theta by cos theta is equal to tan theta. So if we find the value of theta in most of the case in question they ask what is the value of theta, then it is very simple for us that theta is equal to tan inverse mu. What is the value of mu given in the question, that finally put here, and that inverse of tan theta, that called theta, right? The one equation is comes out from this equation.